This video is going to look at how we can use partial fraction decomposition to integrate. So in other words, it's going to let us rewrite complicated integrals that we wouldn't necessarily have been able to integrate before in a way that we can integrate them. So recall that partial fraction decomposition allows a quotient to be rewritten as the sum of simpler fractions. That's the whole point of this. We rewrite the original function as something simpler. And we also know that anytime we have something of the form integral of a over x plus b, that's going to have to be integrated using u substitution. So u is equal to x plus b, du dx is equal to 1, dx is equal to du, a times the integral of 1 over u du is equal to a times ln, absolute value of u, which is equal to a times ln times absolute value of x plus b. So in other words, if our partial fraction decomposition results in something like the integral of a over x plus 3 plus b over x minus 2 dx, say, then we know that we'll be able to integrate this. And that's the whole goal here, is writing something that wasn't integrable originally as the sum of a bunch of these simpler polynomials. And kind of as a, by the nature of this class and the nature of the AP test, everything that you would use partial fraction decomposition on will just be in these simple, non-repeating linear terms. So let's get into an example. We have 3x over x squared plus 2x minus 8. So the first thing we want to do is check, is the order of magnitude larger on the bottom than the top? If so, great, we move forward. If not, you'll have to use long division first to get them kind of flipped around in the right way. Now what we have to do is factor our denominator. So we're going to rewrite this as the integral. So actually, let me just off to the side here work with just rewriting. So we're not doing any integral yet. We're just going to rewrite this. So 3x over x squared plus 2x minus 8. By partial fraction decomposition, we know that there has to be some a and some b such that I can get the expression a over x plus 4, b over x minus 2. And it's okay if you use different factors, or if you put the a and b on different things. You can't use different factors. This is the only way to factor it. But if you switch your a and b, it's fine. You'll still end up with the same thing. So now we have to take our next step, and we say that this is equal to a times x minus 2, because we want to combine these into a single fraction. b times x plus 4 over x plus 4 times x minus 2. So combining these into a single fraction, or starting to work in that direction, means that we know that we can cancel all of our denominators because we can multiply through. So then we get 3x is equal to ax minus 2 plus b x plus 4. So now if we're clever about substituting in x values, because this has to be true for all x values, so if I pick good x values, I can solve for a and b nice and easily. So for x is equal to 2, I get 6 is equal to a times 0 plus b times 6. That means b must equal 1. And for x is equal to negative 4, I get negative 12 is equal to a times negative 6 plus b times 0, and I get negative a is equal to 2. So that means, like we had said before, 3x over x squared plus 2x minus 8 should equal to 2 over x plus 4 plus b, which was 1 over x minus 2. So that means all of that lets us come back over here and say that this integral is also equal to 2 over x plus 4 dx plus the integral of 1 over x minus 2 dx. And now we can start working with these a lot more easily. We know that this is going to be 2 ln absolute value of x plus 4 plus ln absolute value of x minus 2 plus c. Adding these two together, we could do some cleaning up or simplifying, but I'll just leave it as is here. And that's the idea behind integration by partial fraction decomposition. Break it up, write it as simpler integrals to work with, and then solve those simpler integrals.